Hello, viewers. This is Prosthodontics on Friday to solve your prosthodontics questions and give you useful lectures. My name is Jo In Ho. There are different problems that you encounter in prosthodontics. So we are going to look at some of the top issues related to prosthodontics. And as the first lecture, we are going to look into abutment screw loosening, and this lecture will be delivered by Professor Park Chan-jin of the Gangneung Wonju National University Dental School. If you leave questions on our YouTube sites, we'll be more than happy to answer them in the Q&A session. We look forward to your continued interest. So, let me introduce Professor Park Chan-jin. Please.
궁금증을 풀어주시기 바랍니다. 나와주세요.
Hello, I'm Park Chan-jin from Gangneung Wonju National University Dental School. Today we are going to look at implant screw loosening. Actually, this is an area that you are already familiar with in the clinical setting and have also experienced complications. So it's not a new topic. So today I'm going to focus on more giving you in-depth knowledge about screw loosening. Actually, if we only talk about concept, it could get boring. So I focused on interpretation of those concepts in my slides. I hope they are of use to you. So I'm going to focus more on to prevent screw loosening. We do preloading, and I think internal connections is that you use more. So I'm going to talk more about the screw mechanics, so you will get more overall picture. So we call this screw loosening, and this means that screw get loosened or untied. So when patients come with the screw loosening, it's a result of a problem, and as a dentist, what we need to focus is not to let it get loose. So there is a critical phase, in the beginning of a screw being loosened, so that we want to prevent by giving preload. So if you look at that critical stage where it's about to get loose, actually not letting it get loose should be the focus. So the reason for getting screw being loosened is due to various trauma and force being put to the implant. I mean, the diagram exaggerated, but it's already loose, so it's actually being exposed, and this is a typical case. And the cause for screw loosening could be about these areas. So it's related to prosthesis, problems encountered through surgery, and one main example is off-axis loading. So you could think of cantilever. So cantilever means the vertical force or load that is put on from the top part, and there is a load, but the off-axis load means direction from or the force coming from other areas, not directly vertically. So that extreme case would be the cantilever force, and it could be due to the improper design. To have low office loading, you say, to have less force, so the contact of the biting force maybe needs to be a bit weak. So there are various approaches. So you could think of that, but as explained here, the manufacturer implant, there are inherent causes. So when we say screw loosening, for clinicians, we choose a company's implant, and the causes originating from that company's implant design could result in screw loosening. So for clinicians, while reducing the complications of off-axis loading, other things, plus how to manage this inherent design issues of the implant it should be the focus of the clinicians. So if we have screw loosening, then there could be fracture, and the fixture could also break, and then it's been removed. And for a patient, as for a long time, because he or she can still chew, they keep using, but it's loosening, so there's a soft tissue growing there and swelling and other complications. So as you can see here, this is very typical screw loosening, and here it's already loose, and this one there is a fracture, and on X-ray it shows that implant fixture itself has fractured and result in the implant no longer working. So same here again. For a few years it was in good usage, but it swelled and there was blood, and X-ray showed there was a bone resorption and there was inflammation. So we managed that, and a few days later there was a fracture. So loosening resulting complications. I mean, there are few complications, but the loosening is multifactored. So patients, prosthesis, or the original spec of the implant manufacturer all impact on this type of issues. So that cannot be all prevented, but there are ways to clinically manage them. So this is an implant, and inside you see the abutment screw bottom. The thread is inside. So fortunately, if you can remove it, it will be good. But if it's loose and breaks, then the tightened torque would no longer exist, and internal can be removed. But sometimes, initially, before it's untied, there is a loosening, then there's a torque in there. Therefore, unfortunately, implant itself also needs to be removed. So this is a very unique case. So here, cement type was used for restoration, and this is a screw type. And for this patient, here there was loosening, but there was swelling there also. So we opened the flap, and it's a very rare case, because implants, if it's loose and it's used for a long time, then implant itself, as we have seen before, it's not fractured, but some of the platform has been torn. So on the internal type, you have a lot of tear, but it's rare that in external types tears. So we talked about off-X loading, and in prosthesis design, with this could be very frequently reason for the screw loosening. So if you do a lot of restorations, implant placement means using residual bones, and there could be not very ideal conditions. So you need to be very careful. And as you see, it's 4 millimeters, and here is 6 millimeters. So if it goes beyond the force that can be supported by the implant, the momentum, as it gets longer and longer, the screws has to bear more load. So even in the same off-X thing, the load is near the implant or far from implant, there could be such a momentum difference. And the biting surface, you cannot always place it very straight and vertically, but sometimes you have to do angled approach. So from the implant axis, same distance, but because there is an angle, momentum grows a lot. So these conditions result in very bad and inferior conditions, and if it's used for long time, the screw can be fractured, and even implant can also result in fracture. So another example, on the lower jaw side, you see you have the upper restoration, but here you don't see gingiva, so there was about retraction. So here, to implant place and with the GBR, even if you don't do a straight occlusal plane approach, you have to do angled approach. So for prosthesis, doing crossbite is to reduce OFX, but if you don't do that, just do overjet base restoration, then this will be the result. And the implant position is avoid to OFX loading as it goes far. The cantilever becomes bigger, resulting in a more crisis type of situation. So the screw loosening in the external and external connections all happen, but how are they different in mechanics? This is a very beautiful diagram. So external implant, and this is internal implant. And for this, especially for the aesthetic zone, because of platform switching, you use this more, and because it's easy to do surgery, I do believe a lot of people prefer this. So if you see these strengths of internal connection type, there are many strengths of internal type. It has thick soft tissue, has a perfect seal, easy to do surgery, easy to learn the surgical skill, but there are also external strengths, simple verification and others. So depending on what's more comfortable for you, or what kind of prosthetics you have available, you can choose the one that is right for you. Anyways, external implants, there are different types, but still on the top side, it all looks about the same. It's mostly butt joint type connection. So butt joint means it's giving a support. So it acts as a buttress. So the top part, if there's force, then it supports, works as a buttress. So the external connection hex in this type slip fit in the single load restoration, it can rotate in the as an anti-rotation. So that is the slip fit, and in the connection it has a butt type joint type connection. So each company has their own originality in making implant and say they is better than others, but basically external implants are about the same in terms of connection. So the shape, you have this top part, and on the inside, internally, abutment screw tightens. So it looks differently from outside, but when it comes to abutment and abutment screw tightening approach, the mechanism is more or less the same. So not much a difference compared to internal implants. So if you see here, external implant connects to the abutment screw. So again, here preload is used. So this means that the screws has female and male thread, and it goes up to the full length, and screw doesn't rotate anymore, but additional force is given, so that internally in the screw, intentionally tensile force is created, and that tensile force is on this abutment screw's head, and inside the threads on the top side I mean, as later diagrams will show, it will get hooked in there. So this implant, I exaggerate a bit, but once it connects, if you increase the force, it says, like, for example, by 30 Newton centimeters, then like this, as the screw is extended, of course, it doesn't really lengthen the screw, but with the force that tries to lengthen, and if there's a external force, it resists. And that is the concept of preload. And because of this, external implant looks like this, so that in the end, the abutment screw, this type joint here. So here there's a tightening and there's a tensor force on the two sides. So there's a compressive stress inside with support coming from inside. And that is the mechanics of the preload. So this is a cross section. And on the external implant, and this is internal implant. And if you look at the joint, then the thread, by implant abutment screw, some companies have 3 or 4 threads, or some companies has up to 7 to 8 threads. And if you cross-cut it to look inside, then on the right side is the implant inside end of the female thread, and this is abutment screws male thread side. And as you can see, the surface is very rough. So if you look at the implant thread, if you actually cut it and look inside carefully, it's rough. So if the screw has not been tightened or connected, when you first get it from the company, open the box and look at the implant, you see there's been a lot of processing. You sort of do the milling for it to be produced, and that's why the surface is rough. And what is interesting also is that between the mating surface between male and female thread, the distance is all different. What I mean by that is that this is now tightened screw. So this, I said the male thread on the top side, and this is the inside of the implant, and here it meets with that, and the space is all different. It's not different by company, but even within same abutment screw, each of this, if you look into them, actually what you think is actually touching each other, only 2 or 3. So implant screw, just because there are many screws, does not mean there is a lot of connecting force. But anyway, external inflows, if you tighten here, then abutment screw top side and the male thread top side connects, and there's tensile force, and there's concept of the preload, and that's same for the external internal connection. But abutment screw tightening, if you look at the inside, here in the buttress there is a stop in the external type, but for the internal connection type, the conical seal structure, and that is the difference with the external connection type. So again, about the loosening, if you look at the system interpretation of the mechanics, you have to understand that there is a settling effect. So this settling effect means that if you touch the rough sides together, it becomes smooth. So the implant screw, when you first get it from the company and you tighten and loosen repetitively, then the mated surface, first the rough and surface meet, but once it meets many times, it becomes smooth and becomes kind of flat. So settling effect is when it becomes kind of smooth, and that means the flat surface has smooth or flattened, and this one means the coefficient is become lower. So the rough meets rough, then there is a lot of more friction. But once it becomes flattened, the friction coefficient has become lower, so it can means it can tighten more. So for those that study screw, they actually change materials or coatings to make it tighter. But what we are interested is here. So the preload that we have put on a continuous basis, when it tightens and loosens, in other words, the friction goes away and the coefficient goes down, it tightens more. So as the preload goes up, then with the external force comes, and there's more resistance, it will become stable. So when we lose, the preload goes up, and reverse torque is about 10 to 20% lower than the given preload, and that level is maintained, so the reverse torque stays high. But on the other hand, it's flattened, but due to external clinical environment compared to preload, in other words, preloads go down, then the inherent friction resistance goes down and becomes loose. So reverse torque, we anticipated preload comes lower than the force that wants to loosen, and resulting in the screw being loosened. So this settling effect, there are different concepts by lecturers here, but this settling effect does not result in loosening directly. It's inevitable if two rough surface meet. So after surface meet, the preloads needs to go up afterwards, and that is what I want to say. So unlike the external implant, when it comes to internal implant by manufacturer, it looks different. So not only the design, but also the connection area is all different. Some just has the conical shape, or some has the butt. This is the butt type joint, and some have a bevel and then comes internal shape. So it's different. What is mostly common is that they do come with conical seal. Of course, by company, they have their originality. So in development phase, they say theirs is better, and some company had promoted the most taper, as you know. But anyway, this conical seal is the biggest difference from the external type. So settling effect, be it internal or in external type, all have that. But for implant, be it internal or external, the conical seal is for the internal type. And because of this structure, screw loosening could actually be stronger. That is the conclusion I want to give. So for the internal, well, it could say it's the strength of the internal type. Well, you could have to take the parallel X-ray to see it. So for the external, this can be detected with the X-ray. So this is the benefit of the X-ray. But for the internal type, even if it's loosened, it's very hard to detect through X-ray. So it's not different from a few months ago X-ray before loosening. So X-ray detection is better with external. And between the two, is there a difference in terms of loosening? If you look at the literature, the numbers are about the same. On the external type of the 600 implant, about these numbers became loose. And for the internal implant, the numbers are about the same. Of course, it's from the same company, but the numbers are the same. So screw loosening, they say internal is as if there's less loosening, and compared to external, it's better. It's because the external implant has been around for a long time. The root form implant being available and with the clinical results being good. At that time, the implant was external type and screw loosening exists from then. So the strength of the screw loosening existed from then. So internal types were developed in a better condition because it came later. So bad things of the external things, they say, is the now being compensated by the internal type, but literature shows there is actually not much of difference between the two types. And why is it? You have conical seal, and as I said, because of the settling effect, with the full load increase, be it internal external, there is a resistance. And for the internal implant, it even has conical seal. So with the full load, if you put the prosthesis in, there should be no screw loosening. But as you have seen in this literature, there's not much a difference between external and internal type. This is because of this actual displacement, and this is something I want to tell you before I close this lecture. So preload is tensile force within the screw, and the clamping force, the external structure of the screw tightens with the clamping force. So it talks about same phenomena. And removal torque, as I said before, now the settling effect, because of that, it loosened at a lower level than the preload level. So you have, if a small opening but large clamping force, there's no screw loosening. But if you have larger opening force, then of course screw will get loose. So this is not proper example because the material is wood here. So the joint separating force makes it loose. So if there's a separation force, it becomes loose. And as the implant is metal, it results in screw loosening. So with the clamping force, with the preload, and the external force from the clinical environment, joint wants to separate. So it's a clash of these two forces. And with use this type of torque controller for preload, and it's well defined now. You have narrow, regular, as a wide platform, and you choose the right one. And typically about 30 newtons up to 5 newton there's available. And for the internal implant, this conical seal makes the overall axial displacement go down by 5 to 7. So these are the factors affecting preload, and to control this, implant makers do coatings or change materials, or abutment dimension is changed, or also standardize the torque driver. So they try different things, and there are different torque controller. And the Osstem initially had this, but now this type of controller is very similar to another company's one. But what's difference is that this left side I don't use anymore, because these are the manual ones, and the top one was the electric controller. But these two are not the same. Now for this one, they were in place and positioned. This is, you call it ball. You pull it with a hand, and you have gauge, and you pull it as much as the number in the gauge, then the torque put in the implant. But what is here is different. So there is a braking action one more time here. So I'm curious about this. So strengths will be the same, but is this number reflecting this one or this one because of additional braking? Is it has a safety zone? So the action between the two here is different. But my feeling, this one, the bottom one, when you put preload on the maxillary side, I think it's better. Of course, it's not saying that this is bad, but using this bow type is better for control. So that's why it evolved from this one. So in this line, the metal thickness and material would also have an impact. And this is internal and external implants. Now, we talked about the strengths of the two, but weaknesses, the internal, there is this axial displacement. So generally, when you put the preload, and with the biting force, when you chew, inevitably there will be displacement. So there is a tightening, and you put the full load with the 30 Newton, it just stays as is. So there is no displacement because it's a butt joint. But with the internal type, after tightening, if you put 30 Newtons, then it goes down like this. And this is called axial displacement. And so a full load given, it also goes down. And with the chewing of the patient, there's a repetitive force there. It continues. So internal implant by structure inevitably has this type of displacement. So what I'm trying to say is that surgeon tightening, and when the patient uses, so there's tightening and then there's chewing and there's axial displacement, then the full load disappears inside and then result in screw loosening. So internal implant structurally compared to external type, I mean, because there is a conical seal, you would think it would be better, but in terms of screw loosening, there's not much difference between the two. So that's what all the data tells us, even if indirectly. So this is external type and this is internal type. And when you masticate, and as I said, the conical seal design, there's axial displacement. So I mean, it's just exaggeration just for your understanding, but itself is, it's few microns is enough to offset the load. So that's result preload. So that's a result in screw loosening. So internal type, you need some temporization period more than so than external type. So after some usage, you remove that, and final restoration, you give full load again. So that is the way for to make it good. But still, it's would expose to the actual displacement risk. So this is internal implant and bottom is external implant. And this is tighten torque, and you have the settling value. And the red line, you see it's much higher level, and this is because of the actual displacement. And that's what you need to understand. And because that, you take impression and you create wax pattern and you do temporization and then you do final restoration. So you have, you take it out and put it in with different things, and that results in more inaccuracy. So internal type, these compared to its initial strength, in terms of screw loosening, there's a lot of vulnerabilities and weakness. And when there's complications compared to external type, it's worse, gives you worse situation like wall tearing and other things. I'm going to talk about that a bit later. So in clinical setting, this one-piece type internal implant impression cupping compared to two-piece type is not that predictable, because with the cylinder, you tightening, and depending on the force, the actual displacement also occurs. And there's no consistency. So because of there's more variability, there's more unpredictability here. So what are the causes of the actual displacement? I mean, settling effect, I said, exists in both internal and external. So it's because of wedge effect. Conical seal goes down because of force, and it results in wedge effect. It only exists in the internal type because of its structure. So internal joint more stable, that what we thought to be true is actually not reality because of the actual displacement. So these are the external and internal type, and the initial tightening, full load given, and then was reversed. So this is the first one is the left bars. So after a while, compared to external, internal, you have the full load and the loosening. So the force is lower here, and this is because of actual displacement. And what is also interesting is that this axial displacement happens in the beginning a lot, and you have tightening again and then loosening, and actually goes up compared to the first time. So there's a lot of axial displacement, and full load tightening happens again. Resistance increases, therefore resulting the reverse torque going up. So compared to what he anticipated, I mean, just because it goes up, it doesn't mean that's good. There's a lot of offset and loss in the beginning. Same again. This, if you compare the two, between the threads, settling effect, and there's slippage, and full load inevitably goes down. So preload goes down. So because of the settling effect, always it's lower. But in this case, there's also retightening that is required for the internal type. Because of axial displacement, if you tighten once, depending on the surgeon or the lecturer, they say, do it 5 minutes later after 4 times tightening, do it again, whatever. They say the next visit, tighten again. What is important here is that if there is axial displacement, then preload one time is not enough. To control this, to minimize the decrease of preload, internal type must have retightening step compared to external type. Another thing is that internal implant, you have the distance is the same as conical seal. In the clinical setting, if the distance was the same, it will be good. But if you have force coming down and the conical seal, there is elasticity trying to return to the original form, but you also have the force coming from the side, and there is offset also happening inside. So the conical seal doesn't get the load to be the same. So if the resistance is low, one side will be concentrated, and from elastic it will change to plastic deformation. And in terms of screw loosening, this actually worsens the clinical environment, making it come loose more. And this one is narrow type, and 5.0 is the wide type implant. And this is looking at wall thickness, and this is FM study. But if you look at this one, you look at conical seal, the internal wall and abutment wall where the slope meets, unlike the last three, you see more redness. This means that in the internal implant, because of axial displacement, as you go to the narrow platform, wall thickness can happen more, especially bone is not always flat, right? So even if you place implant correctly, after time, microthread being exposed, or because there is a slippage or angled placement, so the thread can be exposed, resulting in this type of situation. Of course, again, it might be exaggeration, but you have to think about this potential risk. So this is important. For internal implant, as you go to the narrower platform, it becomes more vulnerable in terms of wall thickness. And if you, unlike the three, you see there is a bit more narrowness. And here, the mating surface, conical seal, how long it's in contact, or how difference is contact is not that important. But in narrow platform, wall thickness becomes thinner, and if it's thin, there is more risk. That is what you need to remember. And another constraint is that internal implant abutment and the conical seal, and then you have hex. So internal implant in the abutment at the bottom, there's hex, and that helps in terms of positioning, but it's not in anti-rotation structure. In the internal implant, anti-rotation structure has an effect, but internal implant is very small, and it has a tolerance, be it hexagon or octagon, it goes around, rotate. So the hexagon underneath cannot work as an anti-rotation effect. But here, because of axial displacement, the ones with the hex type and the implant one, if the tolerance is designed to be very small, because axial displacement, it can come into contact. And if it is a contact, it will result in fracture, a disaster. So it was well-functioning implant, but sometimes you have this type of fracture, right? So it's broken because there's a loosening, but it's also because there's axial displacement, and if tolerance is very low, then there's a contact resulting in fracture. So it's something you need to be mindful. So wall tearing, I talked about. So this is for internal implant, what you can have on your hand. And this is internal implant. You have this tear in the wall. So narrow platform, biting force, I mean, it's anterior on the upper side. It has been used for a long time, 10 years, but still happens like this. So narrow plant, don't use with the strong biting force. It's not the guideline. You just have to make this depending on the clinical situation. So you have to have some control and make a decision case by case. So this fracture and loosening for internal implant, and this is for radiolucent zone here, and the wall has been broken. So internal implant was not a narrow platform. So this is all because of axial displacement. So we put another internal type again, and this is a very unique case. There was a repetitive loosening, and it resulted in not the screw being broken, but the on top of conical cylinder, the metal portion prosthesis broke. So conical seal was really strong, so I could not remove it. So there is the circle here, there's top of the implant fixture, and this one cut surface is the cylinder of the prosthesis, but the conical seal was really strong. So I talked about the axial displacement as my last topic, and I also talked about preload and screw loosening, and especially for internal implant, structurally axial displacement would be inevitable, and here and in various steps, because of there's a transverse in these complicated steps, screw loosening could happen. So you have to have a good control. So in the internal implant, screw loosening, to understand that you have to understand axial displacement. You have to have knowledge about that, and you have to have tightening and retightening, and that is how you get the control of the situation and have safe result. Thank you very much.
네, 안녕하세요.
네, 감사합니다.
네.
Well, thank you coming all the way from Gangneung for this lecture. Thank you very much for the wonderful lecture. So how did it go? It was really good. I mean, there were really nice equipment and facilities, and this is, my first time here, so I didn't know much about the place, but everybody really helped me, so it was really good. I look forward to your continuing lecture. I hope that we can have you again. That would be nice. Now, to reduce screw loosening in the clinical environment, we often use external or internal connection. So what are the things to be considered in using those external internal implant connections? I do believe those that are listening to this lecture will be they have their own clinics. Some are just starting with the implant, or some are just want to study more. But I think the screw loosening, of course, it's due to mechanical reasons, but it's due to inherent implant functions. So it's inevitable. So, there's a lot of challenging situations. So, you need to be used to using external or internal types, both, but it takes time and it's not easy. So, what I would like to say is that now the biting force, if it's really strong, like in the posterior area, and if you are doing the single restoration, like number 37, 38 on the lower, there's a single missing, or there's natural teeth right next to them, and you want to do single restoration in the middle between the natural teeth. So for those cases, it's better to use external connections, and the diameter needs to be more than the IP platform. I think from structure-wise, screw loosening-wise, that would be better, because the actual displacement that I talked about today, it's inevitable for if there's implant. Plus, if you have to do single freestanding, in that regards, the single in the posterior, because of the continuous axial displacement, and as this is a single implant, there should be some resistance to the loosening, and there should be some anti-rotational force. Of course, the process needs to be designed in that way, but the butt joint type external type is much better than internal type. I mean, internal implant, some people prefer, and there are cases where you need to use that. But external type, it's better to treat any problems and has less problems. So if there is a single on the posterior side, there is an issue with the internal type, there is not easy to remove the screw, or if there's a bone resorption, it's very hard to manage the situation. So if it's single freestanding on the posterior, external type would be my recommendation. And secondly, if there's a natural teeth on both sides, in that case, single restoration, natural teeth is contact point. So that means that the angle of the implant, it needs to be parallel. Otherwise, there could be structural issues. So conical seal, the tolerance on both sides needs to be the same. Otherwise, there could be stress loaded too much on one wall, and when you place the implant, there would be stress. So to compensate that contact point, it's roughly looking at how the implant is going, needs to be as much as parallel, and that's how you need to take the impression. But to do that, from the beginning, using the considering various strengths of the external type, I think it's better to go with the external types. So to avoid those challenges, maybe using guide surgery, I think the past issue will be solved. So I think guide surgery would be better, and for like 37 or 47, using external because of the actual displacement to reduce that type of displacement, yes, it's much better. But sometimes clinically, the hexagon type, sometimes it moves, and that could be, a concern. What do you think? Now, internal is also not free from that issue. As I said in my lecture, the hexagonal external type compared to the internal hexagonal type, it's bigger, and it's created as a slip bit type from the manufacturer, so you can have a structural strength. Of course, if it loosens, you can not have much resistance, but internal is weaker in there. So because of there's a contact in the, wouldn't it be better for internal type? That might be, but loosening, it can be really bad. And imagining the loosening, it's better to and easier to manage if it's external type. So that's why I prefer the external type. And if you look at other people, and if they ask my opinion, I always recommend the external type. Yes, I think everybody has their preference, of course. Now, second question. It's about axial displacement. So the internal type implant, if you do internal implant restoration, any guideline to reduce the axial displacement, don't do in one step. Retightening will be needed. It's my recommendation. So manual controller, you use that, right? So within that range, comply with the recommended values. So first you take impression, and when you create prosthesis, the internal implants, you need to have a temporization period. That is very important. Be it cement type or screw type. Temporization, that period is needed before, so that there's a preload that result in displacement, and biting force also plays a role. So you have to have a temporization period, and do retightening and take impression before you put in the final prosthesis. So again, retightening is a must step in my opinion. So if you talk to the dentist, those that always base their own clinical experience, or some people based in literature. So they say, do 4 times of tightening, or do it once after 10 minutes based on their clinical experience. But I don't think that's meaningful, because there is always biting force. So if you want to stable internal implant, and if you're in hurry, maybe inevitable. But again, temporization period, then confirm the preload again before you move to the final prosthesis. So, tightening, loosening, do it a few times. I think 3 times was valid according to my study for or experiment for a paper. But I don't know whether this is a good analogy, but before you run, you have to have a warm-up phase, right? So, don't run without warming up. Warming up makes it more maybe softer, right? Yes. So when you tighten the screw, how much of a Newton do you use? This is abutment screw. So for that, the manufacturer recommendation is what I would like to adhere. But if it's retaining screw, I use a lot of screw types. I personally prefer that. So that one, I don't use that, because manually, the most important is from impression taking. Having your own standards is very important to control errors. So for retaining screws, now manual torque driver, and the last one I use is long arm, because the torque increases with the length also. Because of the space, you start with a short manual driver for retaining screw. So summary for the abutment screw, what is recommended by manufacturer, and retaining a screw. You start with the short one to make it easy, and the last step is to use long driver and tighten with the hand again so the torque can be maintained. Now, cement type or CAD/CAM abutment, when you use them, in terms of screw loosening, is there anything we need to watch out for? Depending on whether it's external or external, there will be difference. As I said before, prosthesis guideline, the retightening concept is something that you need to think about for cement type or CAD/CAM type, which is popular these days. So if you watch carefully, you will see that for the ready-made abutment, when they fabricate in the lab, especially for CAD/CAM abutment, if you look at inside, sometimes there is a lot of debris or something's remaining in there. And in the lab, unless you are there always telling and be careful not to have the debris, you don't really know how many abutment screw has been tightened. So what I'm trying to say is that inside the cylinder, mechanical fabrication leaves a bit debris, and between threads, the valleys, what you call that, sometimes it looks like a black line. Doesn't lab remove them? Even if they remove all, if you see closely, there's always something remaining. So what I recommend is, if it's a cement type or CAD/CAM type of abutment, now we talked about preload or axial displacement, and you have to control the torque. It's the same here, but the screw loosening is all about there should be nothing inside. Hence, use ultrasound, or like you could use also steam showering equipment or device. So please clean the cylinder, and for abutment screw, it's better to use a new one, fresh ones. The hex and screws, you can never be confident it's completely removed. So when it comes from the lab, ask for the same size, a new one also. That would be better. But it doesn't, insurance doesn't cover that. But anyways, but maybe if you can get a mass discount if you buy a lot from Osstem, maybe. Okay, last question. Now, in case of using digital one guide and it's placing implant in the ideal position, then in terms of screw loosening or fracturing, wouldn't it be better? That's a good point. I think that is the right concept, because we are talking about screw loosening today, but from high level, it's about misfit of prosthesis, or when you have two connecting, there is a slope or angle, and there's like dynamic things in the because of the occlusal plane. So there's a lot of dynamics and complications. So to minimize, in the occlusal plane, you have to make it vertical. That is the basic principle. So guide-based surgery is much better than trying to do it with your hands or manually. I think that would be the future direction. Yes, I think so too. So as you have said, that it's the way, using the digital guide is the way to reduce complications. So, it's much better to reduce complications. So it's better for you to get used to using that type of digital guides. Now, thank you very much for that wonderful lecture. But before I let you go, I'd like to ask, anything you would like to say, the student or colleague that wants to do very good prosthodontics? Well, I'm a teacher, so, I always tell them, everybody to study. But anyway, I think what is important is get as much information possible and make their own and also used it in your surgery skills. That's what I want to say. So you say you get the knowledge in your head and use that knowledge to improve your surgery skills. So you need a lot of practice, right? So you need a lot to study and do the patient treatment also very well and practice, right? Yes. So again, I hope today's lecture and Q&A session has been very helpful to the dentist to learn more about how to respond to any screw loosening situations. Thank you very much. So that was the lecture for this prosthodontics on Friday. If there's any question you were not able to answer, please visit dental website. We will post the answers. And at next Friday, December 11th, we will have another lecture series. This time, we will look at food impact and also mastication. And we hope to see you next time. Thank you very much.